Hey everybody, it's Mr. Roy. Let's have a look at factoring. This is our last part of factoring, our last kind of case, and this is called a complex trinomial. So we've done simple trinomials, now we're going to do complex trinomials. Here's what we're looking for with a complex trinomial. Our expression has to have three terms. It has an x squared term with a coefficient in front of it that's greater than 1. So 2, 5, 100,000. It could be a negative number as well. So it could be negative 16, whatever. But it can't have a coefficient of 1. It's going to be greater than 1 in its magnitude. So it's going to be in this form, something x squared plus something times x plus c. And last, our final answer is going to be written again as two binomials, as you've seen before. But we're going to have something in front of the x in one of these binomials this time. Okay, so very similar to a simple trinomial, but there's a bit more work we have to do in getting this to work for us. So here we go. We're going to have a look at an example and some steps to follow. So here's our example. We've got 3x squared minus 7x minus 6. So this is a complex trinomial because I can see I got that 3 out front, right there. So that's not a 1. It would be with a simple trinomial, so this is our complex trinomial. First, we got to make sure that all three terms are in proper order. We've got our largest exponent of x first, and then our x to the 1, and then just our constant, our regular number at the end. So we did that. Okay, and here's what we're going to do. We're going to rewrite our first term, no change. Rewrite our last term, no change. But we're going to split that middle number into two pieces. We're going to split that negative 7x into two pieces. Okay? Now, to figure out what two pieces we're going to split into, here's what we're going to look at. We're going to have to figure out the two numbers. So if you have a look at my a, b, and c on the sides here, my a term that's in front of the x squared is a 3. My b term is a negative 7. And my c term is a negative 6. Okay? And we need to figure out two numbers that are going to multiply to a times c and are going to add to b. So a times c in this case is negative 18. So we need to find two terms that are going to multiply to negative 18 and are going to add to negative 7. So it's usually easiest to think about this in terms of the multiplying, right? So we're saying, okay, let's think about this up here. I got to multiply to negative 18 because that's a times c. And I got to add to negative 7. Let's try some pairs of terms that would multiply to negative 18. Well, if I had 1 times 1 times 18, that would multiply to 18. I could make one of them negative, and then it would be negative 18. So I can't find a way to make those add to negative 7. What about 2 times 9? That multiplies to 18. Oh, yeah, 2 times 9. I could make one of them negative, and that would multiply to negative 18. And if I made the 9 negative, that would add to negative 7. 2 plus negative 9 is negative 7. Cool. So it's negative 9 and negative 7. Perfect. We've got our two numbers. Or negative 9, negative 7. 2 and negative 9 are our two numbers. 2 and negative 9. Awesome. Okay, so I've gotten rid of the rest of the page, and now we're going to need to play around with these a little bit. We're going to need to trial and error our pairs of numbers. Then we're going to break them, the four terms, into two pairs. We're going to common factor some stuff. And we should end up with something that's going to allow us to do a little bit of grouping here. So I'm going to go and write in my numbers that negative 7x, I'm going to break it up into negative 9 minus 9x plus 2x. So I broke up that negative 7x into two pieces. Negative 9x plus 2x, which is equivalent. Okay, now we're going to do a little bit of grouping. We're going to group these two together, and we'll group these two together, and we'll try and do some common factoring out of each of them. And hopefully we're going to end up with something where we're going to be able to factor out by grouping. So what's our common factor? I could factor a 3 out of both of those and an x. So 3x squared, if I divide out 3x, I'm just left with x. Negative 9x, I'm going to be left with negative 3 when I factor out a 3x. How about my other one, 2x minus 6? Well, let's factor out a 2. That's the most I can factor out of there. I'm going to have x minus 3. Aha! Now you might notice we've got our x minus 3 and x minus 3. Those are the same, meaning we can do a thing called factor by grouping, where we're going to pull out this whole group. I'm going to factor out this whole group. I'm going to factor an x minus 3 out of the first term, and that leaves me with just a 3x. And then I'm going to factor an x minus 3 out of the second term, and that leaves me with just a 2. And this is actually where we are finished. We've done our factoring. And if I wanted to check this, I could take this pair of binomials, x minus 3 and 3x plus 2, multiply through the brackets, and I would end up back with my original amount of 3x squared minus 7x minus 6. Now it makes sense that we wanted to split this middle term into 2, because we can recognize when we're multiplying by doing like FOIL through the brackets, we're going to end up with our first term as our 3x squared. And then for our next term, I'm going to be going, okay, x times 2 is 2x, and then negative 3 times 3x is negative 9x. That's where those middle terms come from that we found, that we figured out by doing our number game. Okay, so let's try a few of these. These are the trickiest kind for sure. They're tough. They're not easy. But that's this is one of the ones we need to do for factoring. So let's try a couple of examples. I'm going to go through some examples right now just to show you how to do this. If you want to challenge yourself to try it before I show you how to do it and walk you through it, I think it's a good idea to pause your video on these examples and then just get through as far as you can. When you get stuck, play the video so you can catch up to what I'm doing and see where you're at. Okay. So here we go. We're going to split this up into some things. I'm going to leave my 2x squared the same. I'm going to leave my negative 4 the same. And then I'm going to split my 7x up into 2 pieces. Okay, what are those 2 pieces? Well, I'm not sure. Those 2 pieces need to multiply. 2 times negative 4, so that's negative 8. They need to multiply to negative 8. And they need to add to 7, positive 7. Okay, so let's think of some pairs of numbers. Well, let's start by going 1 times 8. That's always a good place to start. If I made one of them negative, that would multiply to negative 8. Good. Do those add to positive 7? Well, they do if the 1 is negative. So if I make this negative 1 times 8 equals negative 8, and negative 1 plus 8 gives us positive 7. So those are my 2 numbers. So here we go. I'm going to go 2x squared, and I'll go minus 1x, and then I'll go plus, 8x minus 4. Okay, good. So we broke it up into 2 pieces. I didn't really need to write the minus 1x. I could have just written that as minus x, and that would be totally fine. That's probably more correct. Okay, so let's see what we can factor out. This first one, I can factor an x out of both of those terms, and I'm going to be left with 2x minus 1. And my next one, I can factor a 4 out of each of those. Factor 4 to there, and I'll be left with 2x minus 1. Aha! Those are the same. Great. So this is a little bit like puzzle solving, right? You gotta if you enjoy puzzle solving, you probably like this. Let's factor out the 2x minus 1 out of both of those terms. So I take it out of my first term. What's left over? Just an x. Take it out of my second term. What's left over? Just a 4. So there we go. 2x minus 1 times x plus 4. We've factored it. Okay, let's try another one. Here we go. Ooh, look at this one. 4m squared minus 21m plus 5. Okay, so first thing I know, I'm going to leave the 4m squared the same. I'm going to leave the plus 5 the same. And I know my terms are going to multiply to 4 times 5 is 20. And they're going to add to negative 21. Let's see. Oh, I know. 1 times 20 would multiply to positive 20. It wouldn't add to negative 21. But what if I made them both negative? Oh yeah, that would work. That would multiply to 20 and add to negative 21. So 1, negative 1, and negative 20. Cool. So I'm going to say minus m, that's my minus 1m, and minus 20m. I've broken up my 21m into two pieces. Okay, let's factor them out. I can take an m out of, and again, I'm looking at my first two terms here, right? And my last two terms. So my first two terms, I see I can factor out an m. That's all I got. That's going to leave me with 4m minus 1. My next two terms, I'm going to factor out a negative 5. I can pull at least a 5 out of there. And since this first one is negative, I'll pull out a negative 5. 20 divided by 5 is 4, so we got 4m. And 5 divided by 5 is 1, but I divided out a negative 5, so that's going to be negative 1. And aha! Lo and behold, look at those. They look the same. Sweet. Okay, so let's factor a 4m minus 1 out of both terms. I factor a 4m minus 1 out of my first term. What's left over? There's an m. I factor a 4m minus 1 out of my second term. What's left over? Negative 5. So there we go. I factored those, 4m minus 1 times m minus 5. Now we might have to do some kind of combination. We should always look for an example or a situation where we need to common factor something out first, right? So this one I notice I can common factor something out first. Now are all of these divisible by, say, 4, the smallest number in there? No, 18 is not divisible by 4, but they are all divisible by 2. So let's pull a 2 out of there. That's going to leave us with 10x squared minus 9x plus 2. Now I can proceed as if I'm just doing my complex trinomial. So I'm going to have my 10x squared, I'm going to have my plus 2, and I don't know what I'm going to split this into yet. So let's think about that. I have a number that's going to need to multiply to. 10 times 2 is 20, and it's going to add to negative 9. What number would that be? Well, 20 could be 1 times 20. It could be 2 times 10. It could be 4 times 5. Oh yeah, there we go. Negative 4 and negative 5 would do it. Those would add to negative 9, and they would multiply to positive 20. So let's go minus 5x minus 4x. Put those terms in. Let's do our factoring by grouping. And let's factor out a, let's take out a 5. Oh, I didn't leave myself enough room there. Let's try that again. Let's factor out a 5x out of my first one. So that's going to leave me with 2x minus 1. And let's factor a 2 out of my second one. That's going to leave, actually, minus 2 out of my second one. That's going to leave me with 2x minus 1. Aha! I can factor a 2x minus 1 out of both of those. So let's do it. I'm going to say 2x minus 1, take it out of my first term, what's left over? A 5x. Take it out of my second term, what's left over? A negative 2. Okay, so there we are, we're done. So we did common factoring first, pulled out our greatest common factor, and then we did our complex trinomials. Last one, here we go. Oh, this is an ugly looking one. Yikes. Okay, well I notice I got an A at the front here and a B at the end. So I'm going to end up with something that's got like something A and something B and something A and something B, kind of like that. Okay, I know that's how it's gonna end up. So just thinking about that, I'll be prepared for that. Now let's just look at our general numbers here. I can't common factor anything out. What if I look at my numbers? Yikes. Okay, I got something that's going to multiply to, well, what's 18 times 7? 126. Okay, so it's going to multiply to 126, and it's going to add to negative 39. That's a tough one. I'm going to have to think about this to try and figure out the factors because they don't come directly to mind, and that's okay. It's probably in your mind they don't either. Maybe they do, and that would be awesome. But let's try and think about it. Let's see if we can come up with some numbers. So the easiest thing to do is usually just start with the multiplying, right? So let's say, okay, we could do 1 times 126. Those are two numbers that would multiply to 126. We can't, there's no way to make those add to negative 39. What about 2 times 63? 2 times 63 multiplies to 126, but it doesn't add to 39. There's no way to do that. What about 3 times 42? Aha! Woohoo! That works if I make them both negative. Negative 3 and negative 42. We multiply those together, you get positive 126. And you add them together, and you, oh no, sorry, that should be negative 126 because it was negative 18 times 7. So I need to make the 3 positive. So positive 3 and negative 42 add together to be negative 39 and multiply to be negative 126. Cool. Okay, so we got our two numbers. So let's work on that. Let's go 7a squared. Let's leave that there. Let's go 18b squared. Let's leave that there. Now what are we going to split this into? Well, we've got our 42. So we'll go minus 42ab. And we'll go plus 3ab. Okay, now we're going to need to do a little bit of factoring by grouping. Seems a little more complex with these extra variables, but if we go slow, should be okay. So we'll say, okay, can I factor a 7 straight out of there? And I can. 42 is divisible by 7, right? So I can go 7, and they both at least have an a. So that would leave us with just an a for our first term. And for our second term, 42 divided by 7 is 6. And we factor out the a, we're just left with a b. Okay, my next one, I'm going to factor out both 18 and 3 are divisible by 3, so I'll factor out a 3, and they both have at least a b. So I factored the 3 and the b out, I'm left with just an a here. And 18b squared, I divide 18 by 3, and I get 6, and I factored out one of the b's, leaving me with just one b. Cool. And I notice that these are the same. So I can common factor those out. So I'm going to common factor out an a minus 6b. What's left over from my first term? 7a is left over. What's left over from my second term? 3b is left over. Now if I multiplied all those through, I'd get back to the beginning where I came from. And so I've successfully factored this complex trinomial. Whew, that one's pretty tough. All right. But we're there. We made it. So now you know how to do complex trinomials. And we're going to be moving on and doing some practice and some assignment work from there.